Can you please send? Oh yeah, thank you for starting recording. Sorry, guys, forgot about it. So can you please send, I guess, pluses in chat if you can hear and see me? Okay. Okay, I guess you can see me. In that case, let me share my screen. And you should be seeing my screen now. Let me remove the panel. So yeah, welcome to this free webinar related with Git and version control systems. That is basically will be hosted for next 2-something hours or less. This is basically the first slide of my presentation, and if you're interested, please scan this QR code and you should be able to see an amazing Azure program training for cloud qualifications, so check it out. As original statement for my presentation was saying, this is supposed to be webinar related with the test engineers that are interested in learning the basics of how it is better to work with version control systems, what is GitHub, and basically how to get set up with the GitHub and work with it. So let's move on. Now, a bit about me, I guess you could read that there. So in short, I am a while in IT for more than 10 years now. And at the moment I'm running more managerial work, but I'm still like doing code work, writing tests, and all the usual stuff that all test automation engineers do. So going back to the contents of my presentation, the structure of this workshop will be the following. We will have 2 sections. First section will be theoretical, and second section will be practical. After both sections, we will have Q&A session that will last as long, I guess, approximately half an hour, as you have any questions. And in theoretical part, we will be going through 2 basic topics. First general topic is what is version control system, how it works, what it is, what are the popular version control systems that exist, that are used today. And in short, we will be touching branching strategies topic, which is important too, because it's all related if you want to work using version control system. Second subtopic is GitHub. So it's basically what is GitHub, how to get set up with GitHub, how to use version control systems, and like I will give some samples of the standard production workflows. In practical session, we will start from scratch. I will actually go and create a fresh Gmail account. Then I will go and use that Gmail account to register in GitHub. After this, I will be showing few ways of repository creation and telling you about some additional points you should consider while doing this. After this, I will be showing you some basic Git commands, how to use them, like how to create repository, how to add file, how to commit something, how to push. After this, I will show some basics related with branching and merging changes. And as the follow-up topic of that, we will be creating some files or just copying them and trying to push them to the remote repository. If you have any questions during this webinar, please, I guess, write them down in the question section in Zoom or raise your hand, and I will be addressing all of them in the end of this webinar to make everything a bit more smoother. So just for you all to understand, the idea of this webinar is not to spend 2.5 time of your hour, it's just to give you a general understanding of what is GitHub, what is version control systems, and specifically Git, and answer your questions if you have any. So let's move on. So let's start with our theoretical part. And first topic here is how version control works, why it's needed at all. Like, why can't we just work the way we worked before without any version controls or anything? So First of all, I guess this presentation should be available to you after the webinar. I won't be reading this. I will be like giving a summary here. So generally speaking, version control system is just a system that allows you to create a history of the file creation, file updates, or any changes in your files. And it also should give you a possibility to travel kind of in time to older versions of your files and to return back to the current time. So the whole idea is to have some order in the files that you're using and to be able to have different versions of those files if you need those. Now, second thing, the whole idea of version control systems, it appeared when people started working together on projects, writing code or doing other stuff. It turned out that when you're working alone, everything is fine. You're like adding new files, you're changing files, nothing is messed up. But when there are just two of the contributors in the project, let's say, you're starting to see that sometimes you're trying to edit same files, you're trying to save older version of the file while newer version of the file already was provided by second contributor, and other related collisions. And it actually creates a big issue for the production work in the real time, in the day-to-day life for engineers in IT in general. So the whole idea of version control systems, the way that they were introduced, was that there should be a way to simplify a work of a team of few contributors, and it doesn't matter how many of those contributors you have, 1 to 10 or 100, 1000. So people were trying to find some tools or approaches how to make that work. This is basically the concept that stands behind version control systems. Now, if you work on any project, as team grows, you see that if the processes are not set up properly on your project, you're more and more creating issue cases, working with the same files, overwriting others' work. You're starting to realize that maybe it makes sense to use something that could potentially help you all work together. And this is actually a serious topic because I've actually had experience working in production teams that wasn't using any version control systems, and it wasn't fun. Another important point is that when you even considering using version control systems, you need to think about your project, about your technical stack. If, let's say, you're working on the Microsoft stack, you may consider initially working from under Team Foundation server, because all the tools from the same basically technical stack, they should be aligned better than, let's say, tools from different technical stacks. So when you're even considering choosing version control system, you should be looking at your project, what your project needs. Now, second thing that you need to think about is how easy it will be to learn that system and how easy will it be to actually implement the usage of that system on your project. And third, last but not least, is the community support. If you're using some tool that has very tiny community of, let's say, I don't know, 30 engineers, 50 engineers, you will not go far with that, because in order to keep growing some tool and keep improving it, you need to have a strong community. So these are like the basics of what is VCS and why we even need it. Now, what are actually the benefits of using any version control systems versus not using them? On this slide, let's go through the list of some basic benefits. It's not definitely all of them. I just highlighted the most important, in my opinion. So first of all is version tracking and branching. As I said initially, when you have version control system, you can track different versions of your files, and you can kind of create different historical branches, different outlines for those files. Like you can have one file, but it can be represented in different versions, and you can navigate between those. And this is really important when we're working with code base or any other files. Even when designers are working with design, it's usually really important to have a solid understanding of the versioning for them. Generally speaking, for production, it's drastically important to have a good understing what version of the file was used here and there, what's the stage of the production that we have, what is in QA, and so on. So this all is related. Now, another thing that version control systems provide us with is tagging. So let's say you've implemented a certain feature and you want to have a capability to go back to this same state of your application even in the future when you implement, let's say, next 10 features. Tagging is exactly enabling users to do that. So you're creating a feature, you add a tag, and then you can navigate to that tag and kind of revert work, or you can fast forward work, go into other tag from the future features or something like that. So this is basically another thing that helps you to be flexible in production environment. Next thing is one of the scariest topics is restoring previous versions or even restoring files. Now, the common problem is that when new engineers come to production environments, they sometimes don't feel so well and like comfy in their environment, and occasionally they can delete sometimes things that shouldn't be deleted. Now, version control enables us to restore those files instead of like using some software to restore data from hardware drives or SSDs. It's far more complicated. So version control, it actually keeps a journal of files and their versions, and because of this, we can actually navigate between those versions or restore files or revert version of the file if, let's say, the changes that we did, they are actually breaking changes, nothing is working now. So we need to get our working version back that we had before. Another, and I guess one of the major things here is collaboration. As I said before, when you're working alone, you're just fine. But when there is a team, and especially a distributed team, let's say somebody's in Ukraine, somebody's in Russia, the United States, in India, and we all need to work together, it's close to impossible to like work inside one project and do not cross on the feature work or on other stuff. So version control systems are actually enable us to collaborate better and like to have this process actually working versus just have something destructive and unreliable. Auditability. I guess some of you know, or all of you know, that from time to time, all the projects, all the documents usually go through certain audits. It's when some external company comes to you and looks at your code bases, to your documents, and like they check them. So version control systems, they actually enable us to be ready for audit anytime, because everything is journal basically, and we can either show the latest version of everything, or let's say go back and show previous versions of the files if, let's say, some incident is investigated, some data leakage or wherever. So this is another great feature here. And final point here is ease of integration with IDEs and other tools. Now, when you're implementing, when you're working on any code, you're like implementing new features, obviously it is far more useful if you can just not live in your IDE, press some buttons and push the work that you did somewhere to the cloud. Version control systems enable users with those capabilities, and this is another important point. And nowadays, basically, the majority of version control systems, they actually support lots of IDEs and other integration tools. So let's move on. Next small section is popular version control systems. Here we will have 7 version control systems, and let me name them to you. So first of them is kind of old one. It's called CVS, which is actually looks like VCS, but it's a related thing, but not exactly the same. Concurrent version system. This is actually quite an old system that was used a while ago, and it's actually still used nowadays, but not among millennials or like people from even 90s, I guess. Second version control system is SVN, which is also called Subversion. Third version control system is Git. Next one is Microsoft TFS, or to be more precise, Team Foundation version control. Perforce Helix, Mercury, and Bazaar. So on the following slides, we will be going through each and every of them briefly and talking about pros and cons of each of them. First is CVS. So this system is actually around for a while, and because of this, people think that it's really stable and it's like major technology. Cons that it has: moving files is, or renaming them is, doesn't actually involve a version update, so you don't have to commit this or to like somehow create a history for that. Some people call this a con, but some people can call this like pro, because yeah, well, people different. So, but in general, from my perspective, all actions that are done on files, they should be in history, because what's the sense of using any version control system in that case? Another con is that security risks appear when you're using symbolic links. When you're working with CVS, you have to use symbolic links for files. There is no workaround for this, so we have what we have. We usually cannot do some atomic operations on with files when we're using CVS. So this, as time goes, leads to source corruption, and we have to like do additional maintenance on the code base, which is not great. We're spending time, we're wasting it. And final thing here is that branch operations are expensive, and it's really hard to run branches in CVS. It's actually close to impossible if we are speaking about long term. If you're, let's say, just creating branch today and you're deleting it today, and at the end of the day, you're fine. But yeah, also this version control system is centralized, and one of the examples of such version control systems is Tortoise CVS. So you can Google that if you want. And this is the logo of this system on the right. Next system is SVN, or Subversion. Pros that we have here is it's actually free, so you can just use it. You don't have to pay. Previous one was free, by the way. Another pro is that SVN has a wide variety of plugins for IDEs. It includes atomic operations. It's way cheaper in terms of branch management than CVS is, the previous system. Now, if we're talking about cons, this system still has some bugs, and some of them are really nasty. Whoever was working with SVN, I guess, faced some of those. And the problem is that even though this system is still nowadays used, taking into account that it is not as popular, let's say, as Git, the community is not that wide. And because of this, very few issues are getting fixed, and this is taking forever. So this is an issue actually when you're working in production. Second con is that insufficient repository management commands need to be used with SVN, meaning that they are long. You cannot just like type 3 words and do like moving of the file, or like do some merging or do some updates. You have to type long commands. This kind of nasty. Now, comparing to CVS, this is a bit slower too, but it's newer. So why? It's just the way it's designed and architectured. So it's just a bit slower working with files. And there is no real-time feedback. It means that like you can see in the same second when you're pushing your files of what other guys have pushed, and like do the proper comparison or fetching or merging. Like you cannot basically compare what you're putting to a repository versus what was put by other people, which creates collisions, merge conflicts, and you have to resolve them, which adds more and more time. And this is not great, as you can see. Additional notes here. So this is obviously newer system than CVS. Another thing is that Subversion is like has the widest adoption now. Apache systems use it. Other famous systems do as well for big projects. And there are also a few examples of such tools here. Smart SVN, Tortoise SVN, so you can take a look at those. And this is the logo basically of the Subversion. Git. Git is basically one of our central topics of today's webinar. Now, what are the pros? It's really fast, as I guess the majority of you already know or you want to know. It's actually cheap on branch operations. It's super easy to create branches, to manage them relatively easily, even in large repositories with hundreds of branches. So it's like, it's really efficient. Other than that, Git creates full history of all the operations. And when you're pulling the repository, meaning that you're downloading that repository from the cloud, you're getting the entire tree, the whole history of all the file changes that were ever made on this repository to your local machine. And you can actually navigate through that history being offline. You don't need internet. You can just use it. Now, another great pro, as it turned out, and as time shown, is that the model behind Git is distributed, which means we're not like dependent on a single source server. And it's peer-to-peer model. So like we all can work together. We can share our work. We can push branches. We can push files to remote. We can work with them locally. So it's kind of comfy to do that versus CVS or SVN that we reviewed before. Now cons. If you're a single developer, it doesn't really make much more sense for you to use Git for your local work, because you can just work. You don't need any additional tools. And comparing to Linux and macOS, Git actually has some limitations while running on Windows, and I will be actually showing you some of those maybe on the practical module of this webinar. But yeah, there are some limitations basically related with the fact that Linux has certain architecture, macOS has similar architecture because it was basically built on that, and Windows has a bit different approach to manipulating data and everything. Additional notes here. So as I already said, the model of this tool is distributed, which means there isn't one centralized code base to pull code from. You can like use it on your machines freely, and different branches are actually holding different parts of the code. This is possible. You don't have to store everything in one branch and like have everything in one place. You can do that if you want, but this is not necessary. Next version control system that we will be reviewing is Team Foundation Server version control system. Now, TFS itself can work with the TFS version control or with Git. But for this specific case, we're just reviewing the version control of the TFS itself. Now, pros here are that it's actually well integrated with all Microsoft-based tools, including Visual Studio Code and Visual Studio General. Cons that you can face: if you're not, for instance, Visual Studio user, if you're like doing Java and you're using IntelliJ IDE or any other IDE, it doesn't matter. It may be not that great for you, but still ways that you could potentially somehow hack your way through, but it will be a pain, and why would you do that? There are some issues with pulling stuff. It can be slow, but it can be fast sometimes. Personally, when I was working with TFS version control, I noticed that sometimes for basically no reasons, there are like some speed issues that are not clear. So you have to investigate usually those. Branching actually leads to conflicts when there are a lot of branches in TFS, and it takes additional time for you to resolve those. So just please consider that as well. And you also have to have central repository that also requires connection to safety work. So when you're disconnected, you basically cannot do much with that. The additional note here is that if you're on Microsoft stack, you basically can just stay in that stack and do all the things that you need, basically for all your production lifecycle, from the development to testing to deployment. Another thing, as I said, is that TFS can actually work with Git, which is great. Another system for control versioning is Perforce. This tool actually paid, and it's pretty expensive, but on the other side, it's very extensive and well organized in terms of the tooling inside the tool. It's pretty easy to get used with the major operations and start working with it. You can actually even customize history with Perforce, and it actually has some cons working with big data data sets, but not with multiple data sets, just with a singular data set. Speaking about cones, as I said, it's commercial, you have to pay. Sometimes it can be difficult to learn a bit for people from going from certain stack or certain tool set. And also when you're working on multiple workspaces, let's say you have few projects as a manager or as an engineer that you have to contribute to, you can get some issues because Perforce has some issues managing different repositories locally. This is true. And also there is sometimes not the best UX that you get working with command line with Perforce. So yeah, please consider that. Originally, this tool was just called Perforce, and yeah, just got renamed a bit. Next control version system is Mercury. Mercurial. So yeah, just I call it this way. The pros here is that it's freeware, it has distributed model, it's relatively easy to learn. Even having server is not required, which is actually a great feature. Cons are that merging process is well designed, but you can have some serious conflicts that are getting some serious time to resolve. It's also extension based rather than scriptability or scriptable based. So it basically means that you have to write extensions versus you can just write scripts and modify the behavior of the Mercurial. So this is just an additional point for you to consider. And Mercurial also has some issues working with big data sets, so it's just slow at the moment. One of the examples of such tool is Tortoise HG, so you can look for that if you want. And our final version control system is Bazaar. It's freeware, it's simple. You can even actually track empty folders here. You can rename files and you don't have to create new commits for that. It's questionable whether this is a pro or con. I guess we can argue about that. You can work offline using Bazaar. And speaking of cons, it's actually developing slow. Tool itself, meaning that there are some features that were promised for this tool, but they are not still there, even though time passed, deadlines passed. So the community is not wide here, and it has some issues working with large files. So with small files, it's totally fine, but if we go, like, let's say, beyond 1 gigabyte, you're starting to have serious issues. This project was initially a part of GNU project, which is basically a freeware software operating system that you may heard of. And also there is a company called Canonical that supports the development of this project at the moment as well. Let's talk a bit about branching strategies. Now, there are like tens that I recall of branching strategies that you can Google in the internet, but let's just review few of them, most popular based on my production experience that are actually used in production. So let's go through them. First branching strategy is basically feature-based. So on this schema, you can see that we have basically 6 branches. And branch basically means that you can imagine tree. So tree have like branches going in different sides. But on the other hand, each branch has one mutual part, like the major part of the tree. So when we're speaking about branches in version control systems, it basically means that we're like creating additional forks from the main set of files and doing some modifications. And then we do some additional actions on those files. And if all is fine, we're adding that work to the major branch that we had. If what is branch is still not clear for you, please ask this after the webinar. I will answer that, not to stay here for long. So on this specific flow, we can see that there are 6 branches. Main branch is basically what was previously called master, but GitHub no longer uses master as a major branch name. We have main now. There is also a hotfix branch here, which basically is used when there are some hotfix activities that we need to consider, do some small fixes or something, or add something small. There is also release branch, there is a develop, and there are 2 feature branches. So as you can see, we're creating a develop branch from main branch initially, and develop branch is working for us like a trunk. Basically, this is our branch for merging our work together that we're doing for different features that is done by different developers. So develop is just a point where we come and we put everything that we have. It should be always deployable, but we will not be deploying in this case any releases from the develop branch. All the releases are being deployed only on release versions based on the separate release branch. So as you can see, when let's say work for feature A is done, we had 2 commits here. We're like passing some traditional rituals and getting our code added to develop branch. And after this, we're creating new release branch from develop, and we're basically releasing stuff from this branch. And after everything is released, after all the checks have passed, we're adding our code to main, and only after this we're actually doing the production release full scope. As you can see in notes, in this specific use case of the workflow, all the branches are present in local and remote repositories, and releases are done from main, as I said before. The next approach to branching is actually called GitHub Flow. In this flow, we're just have our single main branch that we use for all the production deployments, main, and this is basically the only branch that we have in our repository, in the remote repository, in the GitHub. All other branches they just are being worked on locally, and whenever they are ready, pull requests are created, and those branches are being closed and deleted. This way, we are saving space in the repository, and we don't have lots of outdated branches in the repository as well, which is a great thing always. Next strategy to branching is actually related with the way that we're working with our production process. So in this specific example, we have a staging environment, we have a pre-production environment, and we can actually have a production environment. So we will be having 3 branches representing those 3 environments. And releases in this specific case are done from production branch. So whenever everything is ready on the main branch, we're deploying staging to run some tests, some CI checks, some manual tests, some automated tests. When everything is fine, we're actually deploying to pre-production branch and deploying that branch to pre-production environment. If everything is fine there, we're deploying to production and do our final tests. So this is another approach. In this specific approach, we just have 3 branches versus creating lots and lots and lots of branches. And one more branching strategy that I wanted to show you is actually related with a more complex approach. When we have a main branch, we use our develop branch as the main integration branch, which basically means that all the features that we are working on, they are being added to develop branch. Then when we think that we are ready to release some features, we are creating separate release branches from our develop branch. We actually deploy code from release branches, and after this, we're merging that code to main, creating tags. As I mentioned before, we can use these tags to roll back if we need, or to move forward if we rolled back previously. So this is another approach for branching in production. And speaking from the general production experience, I guess all of them have some pros and cons, some issues with merging, some additional headache cleaning up all the branches. But choosing any branching strategy, you should think specifically about your project, about your toolset, and about your team. What team wants, why they want that, or what will be the best approach to use the toolset that we have and the team that we have, and other things to consider in production. So yeah, this was basically the overview of the 4 branching strategies that you can use working with Git, or honestly speaking, with the majority of version control systems. Now let's talk a bit about GitHub. This will be a very short introduction. I guess the majority of you here know what is a GitHub. Right now, GitHub basically the largest development platform that you can find in the internet. It's the largest community of the developers and IT professionals. It has lots and lots of repositories, free, open repositories, closed repositories. Free repositories can be forked, which means you can use the repository as a base to continue work, to do some additional work to extend that project. And at the moment, 3 killer features that GitHub has is basically forking that I just mentioned. Pull request management. Pull request is basically when you as a developer created certain code and you want to have it reviewed and you want to have it added to, let's say, develop branch. So you create a request to review your code and have it added to the major branch. The UI and the overall user experience in GitHub for pull requests actually improved a lot in the last 5 years. It's actually super great if you try to work there. And another feature is merging. Merging is considering now some automatic gates, like running unit tests, running some additional checks, running pre-deployments. So this is another well-designed feature of the GitHub that actually adds more fans of the GitHub nowadays. The major specific of the GitHub is that it's basically a GitHub hosting service for repositories. Yeah, and it actually has a nice graphical interface. And it's actually a great place to collaborate and chat and create tickets and so on. So you can even actually work based off the GitHub without using any Jiras or any other project management tools. If you, let's say, have a small team and you don't need to coordinate lots and lots of people. Next subtopic is GitHub and version control systems. So from all the version control systems that I briefly described on previous slides, there are only 4 that at the moment supported by the GitHub. First of them is Git, second is SVN, third one Mercury, and fourth one Bazaar. So yeah, if you want to use GitHub, you should know that you cannot use, for instance, CVS with GitHub at the moment. You can just use these 4, and that's it for now. Now let's review some standard production workflow, just to give you a brief example of how things work in production. So here I'm giving an example of a GitHub flow. This is a small flow, so we basically have a main branch that is default branch in the repository when you create it. Then we're creating a separate branch. We're doing some work there, adding some changes, implementing features, or doing some bug fix. At some point, we're creating pull request. When that pull request is opened, we're actually getting feedback from other developers, QAs. If everything is fine, there are no issues, no considerations, no requests for changes. The changes are actually being tested in automatic mode in the usual GitHub flow now. And after this, they are merged to the main branch. And after this, you can deploy your code from main branch and anytime you want. So this is just a brief example how people work with GitHub. That's basically it. Okay, it's time for practical section. Let me switch to my browser. And as I said before, let me start from registering to, let me move the panel to the bottom, from registering in the Google. So I actually have prepared some credentials that I will be using. So I'm just creating a fresh account in Google that I will be using to register in GitHub after that. Okay, something. Oh, too many Gmails, sorry. Okay, let me use that password that I wanted to use just to make it consistent. So I'm just creating a fresh Google account here. And they want some confirmation from me. 1 second, let me in that case use a different account that I already have, that I've created before while preparing to this presentation. I guess you can accept this. So initial step is just go and create a Google account. Since I've already created a few today, obviously they won't allow me to create another one. They want my SMS. And I don't have phone at the moment handy. So yeah, I'm logging into an account that I've already used to kind of register in GitHub. Right now, just logging into Gmail to be able to receive emails. And let me log into GitHub, and I guess I will try to wipe out my account to recreate it again. I think it should be possible, but yeah, I haven't tried this before presentation, so forgive me if it will. What? Okay. Oh, the password should be different. Sorry. Okay, let me go to settings. Yeah, I guess let me go here, hoping that I can still delete myself. Oh yeah, thank you, GitHub. So yeah, now I'm demonstrating you how to delete an account if you're interested. As you can see, GitHub asks for additional confirmation that I am really intended to delete my account. Think again, stop. Let me type and delete my account. I'm deleting my account. Okay, and I'm being logged out to the site. Now, this is GitHub home. You can basically find all the necessary general information that you can be interested in regarding GitHub. Here is pretty interactive and cool. So please just go to github.com and scroll through it and read through it. It should be pretty engaging. Now let me sign up for an account as it was promised. I will be using same email. And I'm being redirected to the next screen. I'm pressing continue here. Create a password. So let me just use the same password. At the same time, we're testing how GitHub handling fast removal and addition of the account with the same credentials. What was the username? To have a great test of the GitHub account resurrection flow. This was the username. So I'm just using the same data that I was using before creating this account for preparing basically for this webinar. Would you like to receive? No, thank you guys. No, not today. Start puzzle. They want to see if I'm a human. Spiral galaxy. Okay, I guess this is spiral galaxy. Yay. This is spiral galaxy. Great, I'm human. Create account. Okay, so I've been emailed a GitHub code. Let me open 199.610. 199.610. GitHub is requiring some additional information. How many team members? It's just me today, only me. Yeah, let's say I'm a student as well. So yeah, I will not be. So on this page, you can actually specify the features that you're interested in using. Like if let's say you want collaborative coding, you should select this. If you're coming here for improved automation and CI/CD, you check this. If you want security, basically GitHub requires some 2FA and other security measures. You check these client apps for like desktop or mobile applications, project management features, team administration, community. So you can just choose some of these features that you're interested in. If not, I will just pass for now and just press continue, because we're here just to see how it works. I will go, so as you can see, there is free plan and GitHub Pro plan. Since I've chosen that I'm a student, it has some additional discounts and benefits, but we will go with the free plan for now. And we're traveling through space. I actually like this animation. My dashboard is initialized. So I'm in my account now. Let me remove this nasty zoom things. So as you can see, there are different sections. There is a feature preview where you can go and look through the new features. So yeah, that's basically it. We're set with the account. Let me just, to be sure, sign out and sign back in to see that it actually works. And what was the password that I used? This was the password. Let me sign in. Okay, I'm here. So I guess it's time to move to the next point in our presentation. Yeah, and so also some additional notes regarding registration on the GitHub. So all you need, as I said before, just a very non-previously registered email to sign up with GitHub. You also need to set up a secure password. GitHub actually requires your password to have letters, digits, and some special characters. And also, there are some additional scripts that are checking your password for the hackability, basically, whether it's super simple like ABC123 that everyone uses, and you cannot use such types of passwords at all. You won't be able to set it. So once you have email and password, you can just pick a username wherever you want. For username, you can use just letters and digits. And yeah, as you could see, you can just go initially with the free plan. And for my personal needs, for instance, for years, I'm just using free plan, and that's enough. So yeah, let's move on. Repository creation, this is fun topic. So before proceeding with the practical tasks, let me give you some additional points. So in GitHub, in order to work with GitHub, you always need to create a repository in the GitHub. Even if you already have a project on your local machine, still you will have to go and create a project in the GitHub initially. You cannot just push it to GitHub and GitHub magically creates the project for you. This is not how it works at the moment. Easiest way to work with a GitHub is actually either GitHub desktop application or Git graphical user interface. And both of those applications actually allow you to push your changes, basically to send your changes to sorry, GitHub repository over HTTPS protocol. Why am I saying this here? Because if you will try to push changes from the console, I will show you this later, you will get an error. Right now, you cannot push changes using HTTPS and Git bash. You have to use SSH to push changes. Again, if you're creating a repository in GitHub, you can clone it over HTTPS or SSH. Sorry guys, I'm coughing a bit, 1 second. So you can actually clone over HTTPS or SSH, and I will show you this But even if you clone using HTTPS, you won't be able to push code using HTTPS. This is important to understand because it can be pretty frustrating and take some time from you. Now, in order to be able to push changes from git bash, it's a command line that goes with git tool, you need to use SSH. And in order to use SSH protocol, you need to generate an SSH key that you need to add to your GitHub account. And in order to be able to use this SSH key, you need to use SSH agent. I will show this shortly in the practical task. Now, before you do any commits or you add any files or you like that, please be sure to check your username and your user email in this specific folder and repository that you're working in, because there can be some nasty conflicts when you're like trying to push stuff to a repository using some different account from some different project or something like that. So please just consider that. So yeah, let's move back to GitHub. And let me create a repository. I will be just creating a fresh repository in GitHub. Let's call this repository test repo without underscore even, just test repo 1. I'm just setting some test description. It will be public repository, which will basically mean that anyone can access it. And from scratch, I also want to have README file. I want to have gitignore file. Gitignore file is a special file that says your GitHub instance to ignore certain files in your folders. It is useful for log files, for some other files that are not like kind of solid part of the project, that are just runtime things, for instance. So I'm using gitignore with template Java, for instance, and I'm also using a license. So in license, I will be just using mid license. It's free license. So I have basically filled this form, and I'm creating a repository, pressing this button. So repository is created. Now it has 3 files: gitignore, that by default, since I've chosen a specific template, has some information in it. I can explain this later. We have license. This is a standard license, nothing special here. And we have README. README is basically this. It is shown on the home page. Now, let's say I want to work with this project, so I want to clone it because I created it for some reasons, right? As you can see, I have 3 options to clone the project. I can use HTTPS protocol, I can use SSH, but in order to do that, I need to create new public key. And I can also use GitHub command line instruments that go with the GitHub desktop application too. So let me just show you how it goes with HTTPS. I have just copied this link. Let me open my Git on the local machine. Let me navigate to my demo folder. So I want to clone the repository here. I have copied the link. I'm on Windows, so I will be using now Shift and Insert to copy paste the link that was copied. So I want to clone it. Let me clone it. It is successful, as you can see, no issues, no anything. I have a repository now. Let's go to my machine now and check how it actually looks, right? Because who knows? So let me go to my computer, my demo folder. So this is my repository. As you can see, I have enabled in Windows visibility of the hidden files. So Git itself is basically this. It's hidden folder with hooks, info, logs. It's basically journaling and some additional descriptions and configurations that are used. So I have 3 files. Let's say since now I have my repository locally, I want to see what's the status of this repository. Do I have any pending changes? Am I behind the remote repository, or what's the status? As you can see, when you're trying to use Git commands outside of Git repositories, you're getting an error that is saying, hey, this is not a Git repository. This happened because I didn't change directory to my Git repository. My Git repository is this. So I'm switching to that repository. And now, as you can see, in the command line, I have a branch specified. By default, it is main, as I said before. So here I can actually use the command git status. So I've ran it. Latest version of the git bash has actually some built-in monitors, daemons, that are ran, but we will not be going into depths here. So it's basically saying I'm on branch main, and I'm up to date with the origin main. Origin main for me, in simple words, is basically this remote repository. Now, if let's say I want to add file, I will just use web interface of the GitHub, and I will go and add file. And let's say I will be using something from another demo attempt, and I will be using Microsoft Flow, let's say, to upload it. So you see that file got attached, and if I want to edit, I need to actually provide a commit message, add in logo file, let's say, optional extended message. I don't need this. I will be committing changes. Committing changes is basically adding another journal historical note that I have added a file and adding some comment to this. This is the comment, by the way, adding logo file. So I'm committing changes, it's processing, and now you can see that I have 4 files, right? So let me go back to my local repository and run the same command, git status. You see, it still says your branch is up to date with origin main, but this is strange. I can't be up to date because I have just added file. How that possible? This is because my local repository, it doesn't yet know that there were some changes in the remote repository, in the cloud, in the GitHub. Now, in order to check whether there were any changes in the remote repository, I can use a command called git fetch, which basically will go and check what is the list of the files of the commits in the remote repository versus my local files and commits and everything. And after this, when we will run git status, we should be able to see that I'm behind the origin. So let's try that. You see that there was some delta, something was transferred. So let's run again git status. I'm behind 1 commit. So if I want to be up to date, I can use a special command called git pull. Git pull basically downloads all the data from the remote repository in the GitHub on the cloud to your local repository. It's kind of figures out delta between your local instance of the repository and remote repository and resolves it. So basically makes the repositories the same without deleting anything, just by adding stuff to the local repository. So let me try to use git pull. Okay, something happened. Obviously, it pulled file. It also pulled commit because these are the hashes of the commits. Hash is basically alphanumeric instance of the symbols that is used to code something. In our case, it's just to sign commits, to sign different instances of the history in our Git journal. So let me try to run git status again. I'm up to date. Now, if I, let's say, want to create a file here, let me just use touch. Git bash, it actually uses embedded Linux command line, so I can use here Linux-based commands that I normally cannot use in command line of the Windows, just FYI. So touch test text file.txt. This command should create a new file in my local repository. So let me try to run git status again. And here you can see that my file got created. It's red because it's on track. Git sees it. It's not in the ignore list of the Git, and it says that, hey, there is a file that is not tracked by Git. Do something without it. Delete with it. So delete it or keep it. So let's imagine that this file is actually useful. So I want to add it to my Git, local Git. In order to do this, I can use this command git add and specify the file name itself. Let me execute that. Now let me try to run git status again. As you can see, the log changed. Now it says new file, test text file is actually under git. And now I need to add some command to this, because in order to create commit to add another change to my journal, I need to say something about it. So in order to commit changes that are added, there is a specific command called git commit. Then flag m used, which basically stands for a message. And here my message will be just created new text file. Okay, so I created a new commit here. Everything seems fine. Let me try to run git status again. Now, git status says that there are no uncommitted files or there are no untracked files. And I actually have one commit and I'm ahead of my origin repository. Ahead basically means that I have locally changes that are not yet in the remote repository, not yet in this repository. So if I refresh, yeah, you can see that there is no my famous text file here. So let me go back. Now we want to push these changes to a remote repository, right? In order to do this, we need to use a specific command called git push. Now you will see the thing that I was mentioning a bit before. At the moment, using git bash, this is git bash, you cannot push changes using HTTPS protocol. Plus, on my local machine, I have few GitHub accounts in different folders. For some reason, it goes and checks for my another username on the GitHub. And this is not actually the issue of the username, which it initially seems to be an issue of a username. So in order to be able to push anything, I actually need to use SSH key if I want to use git bash. Now, how can I use SSH key? Let me go back to GitHub and try to do some updates to my profile. Let me go to your profile. This is my profile, edit my profile. Oh, no, sorry, this is wrong screen. I need to go to settings actually to change the, to actually run the update of the SSH key. So here in settings, we have SSH and GPG keys. If you open this, we can actually add new SSH key, right? But the problem is that at the moment, we don't have anything to add. So how can we generate new SSH key? There are lots of articles how you can do it, but in short, let me go back to my git bash, move this zoom panel that I'm not sure if you even see, but I see it's annoying. And let me execute command called SSH key gen. This should generate for me a pair of a public and a private SSH key. And it actually asks me for a file name. So let's use test SSH 0826. This will be the name. And in my case, I will be not using any passphrase. Passphrase is basically a password that you should use for SSH to protect it, so that anyone else can't use it. I will just skip it again. And as you can see, I have new SSH key generated on my machine. And I have the fingerprint displayed here, but this fingerprint is not exactly what GitHub wants from me, right? Because if you go back, It actually says the key begins with SSH, RSA, or other prefixes. So yeah, this doesn't seem to be enough. Let me maybe go to my folder locally. And if you recall, this was the name that I used for my SSH key. So these are basically two SSH keys that were just generated in the console. They were just generated in the same folder. Public key has an extension pub, and the application that works with this is actually Microsoft Publisher, but let me open it with Notepad. So if I remove this fancy panel once again, this is basically my public SSH key that GitHub wants. It's pretty long. Let me copy it and go back to GitHub and paste it. This is how it looks. This is a long sequence. Test key, let's call it this way. And this is the way I can add it to my account now. I've created a key, right? I've added it to account. Let me try to push again. Maybe I will be lucky this time. Again, this panel. So I will be just using the same command called git push. Okay, for some reason that didn't work. This is strange. Maybe I know that I cannot use HTTPS protocol, and in that case, I need to go to Git folder, find the config file, and try to edit it. Let me open it in Notepad. So here, I basically need to change the protocol. Now it here says HTTPS. Let me change it to SSH, and here it should be like this. So let me save that, right? Now, when I will try to push something, it should be using SSH protocol. Let me try that. Oh, it actually does. You see, it asks me for my passphrase, but the problem is that this is not the file that I've created. This is not the SSH key that I've just created. This is my default SSH key. On Windows, SSH keys are like placed here by default. So if I will just press enter on my machine, it says, hey, permission denied, you can't use this. So the problem here is how can I exactly use the SSH key that I just generated? And there is actually a way for this. Git bash has an embedded SSH agent program that can be used to manage keys. So let me call it, and I don't recall the code, and it should be somewhere in the presentation. 1 second, let me open it. Yeah, so this is eval $SSH agent test. So let me try to run this. Okay, that seems correct. Let me execute that. Agent P means that the process was started. Now, if I want to add the key, I need to use the following command, SSH. I don't recall. Yeah, this is SSH add, and I need to specify the name of my SSH key. So let's go back to our repository that we created, and the name of our key is actually test SSH. Is basically this one. Test SSH. You see identity was added, and right now I should be all set. So what happened? SSH agent actually will be using now the SSH key that I have just generated versus the default key that is on my machine on C drive. So let me try to push again. Success. You see now I was able to push changes to my remote repository. Now let's check whether it's actually true looking at the repository. And I'm switching to many screens. Sorry, guys. Let me move this fancy panel once again. This is our repository that we created. and I expect to have my text file here. Yay, it's here. So basically, if we go and open commits, the timestamps of the commit is when I actually created it on my local machine. So I was able to push changes to my repository through the Git bash. Now, if let's say vice versa. So for this flow, I was creating a repository in the GitHub itself, and then I was pulling the repository to my local machine. Now, another use case is when I have a repository on my local machine and I want to push it. How can I do that? So let's try that. Let me go back to our Git bash, and let me go a bit higher in the hierarchy to the root folder. Here, I will just create new folder called new repo. Let me check if it was created. It was created. Now I'm going to new repo. And if I want to make new repo a GitHub repository, I can use a special command called git init. This initializes empty Git repository. Now, if we go back to our folder and see how that looks, so we have new repo, and at the moment we just have a Git folder here. That's it. So let's add something here. So first of all, as you can see, now additional step that we need to do. Initially, when repository is created, as it was before, default branch called master. I need to create a new branch called main in order to be able to push it to GitHub. So in order to create branch, I can use a specific command called git branch, and then I need to specify the name of my branch. In my case, it's main. Git branch main. Ooh. Okay. That didn't work for some reason. Okay. Let me check why that happened. Let's actually try to use tutorials from GitHub. Why not, right? So if we go back and we, let's say, want to create new repository, but let's say we want to import repository, right? Because this is what usually. So on this page, as you can see, you can import all files, but it basically provides you with the capabilities to import some VCS repositories like SVN and other stuff. So in my case, this is not what I exactly want, but as you can see, still, even if I want to import my Git local repository, I need to create a GitHub repository initially. Let's do that. Why not? Let's actually name it the same. We can name it differently. Let's call it new repo remote. It is public repository, begin import. Now I should see this screen with the instructions. For some reason, my screen hanged a bit. Sorry. Let me refresh. I don't know, maybe. Okay, I guess it still requires a link here. So yeah, let's go back. Let's just try to find out, like, let's just create new repository, and then we should be able to import it. So let's call this new repo remote, as we wanted before on this page. It's public. Let's, in this case, not add any files, just to see how that works. So yeah, on this setup user guide in GitHub, you can see few options. You can either create a new repository or, for instance, push an existing repository from a command line. So as you can see, I need to execute these commands in my command line. Let me try to do that. Okay, adding remote was successful. Oh, the identifier is actually M large because this is like a special name. So let me create that main branch. You see it was created and checked out. The M actually does that. And now what was the next command there? I've created local repository. Now I want to push it. Yeah, let's try to do that. Okay, for some reason I wasn't able to push anything. I guess the issue here, and it's actually the issue, that my repository is empty. It has no files, no commits, no anything. So it's kind of bad learning case. So let's just create some files and just try to commit them and to push. So let's use our old famous command called git status. This one. As you can see, we have a new document that is not under Git. So let me add it. Actually, you know what? Let me create one more file. Here, right? Then run git status again. Now we have two files. Instead of adding each file one by one, I can use git add and just dot. This command adds all the untracked files under Git. This is pretty useful and it speeds up the work with the Git. So let me execute that command. And after this, we expect to see doc and tests.txt under Git. Let's run git status. Yes, they were added. Now, as we did before, we need to do git commit and we need to write some message. Let's be very short here. Okay, commit was successful. Let's run git status again. On branch main, nothing to commit. Working, tree clean. Let me try to push again. Oh, you know what? Let me try to push using GitHub Desktop. Why not, right? Because I was mentioning it, but I never shown it. Sweet Lord. I want my desktop back. 1 second. Okay, yeah, I guess I have to go. Yeah, so let me show you GitHub Desktop. I have actually downloaded it, and your account token has been validated. And do you want to sign in again? Yes, I will, because I was deleted account. So yeah, obviously this is expected. Let me move the season panel on the right. And this is not what we want to use here. And this is not, so like, where's our credentials? These are supposed to be somewhere here. So let me dig them up. These are our credentials, so I will be using this email and this password. And I will try to sign in. As you can see on this page, I need to authorize my desktop app. I'm trying to do that, so yeah, I'm authorizing it. And after this, browser proposes me to open actually GitHub Desktop. So I'm opening it. It's syncing now. Yeah, I guess it just synced. Okay, this is something strange with the repository itself. I guess I would need to I would need to use a bit different, like I would need to wipe the application and install it from scratch. Something went sideways. So yeah, let's go back to the old ways then, because we're hardcore. Why not? Let's try to do git push. Okay, it seems that we're missing upstream branch. This basically means that, yeah, we need to set this branch. Git bash even provides the command to do that. So let's execute that. Upstream branch means that my local branch should be tracking some remote branch in the remote repository. That's basically it, nothing else. You see again, same thing, because like using git bash, you can do much without SSH. So let me do same manipulation, but faster this time. I just want to show you how I can sync the local repository that I have and kind of upload it to GitHub. So I'm going to config as I did before, editing with Notepad. So here I just need to change URL to SSH here, and here I'm adding git at github.com, saving this. After this, since I already have SSH key for my account, I can use it again. Let me just copy it, not to specified paths, because like it's pretty late on this Thursday. So yeah, I'm just copying two keys. I actually need only private one. I'm just like doing additional work. So let me, I need to start SSH agent again. Where was it? This is the command. And second command for that was actually SSH add and key. And now I can try to push to kind of link my local branch with the remote branch. Yay, it got linked. So I actually push changes and my local main branch now tracks remote main branch. Now let's see if our two files have actually got pushed to the repository, or this is all not true and this is not right. So let me find the window in the repository. This is the window. Yeah, this is our repository. So let me refresh it. And yeah, we have our files here. We have one commit. So we basically uploaded our local repository to the remote repository. Now, let's go back to presentation. I kind of went through the commands and everything. So using the basic git commands, we have already seen git clone, git init, git status, git add, git rm cache. This command is actually useful. So let me show you that. Let's say I'm creating some, let me just copy some file to my local repository. Let me just go and copy, let's say from this, again, our logo. So I'm copying it here. And let me run git status again. And as you can see now, we have 3 untracked files here. So I want to add all of them. But wait, this was a mistake. I didn't want to add all 3 of them. I just wanted to add Microsoft logo. So how can I reverse that? So that command git, this command basically git rm cache, it actually does that. So let me try that. Sorry, I keep switching. Cached, not in caps. Cached. And let me specify the name of the file that I want to be not. No, actually, let's first try see if those files even got added under Git. As you can see, they all 3 were added, and now we need to remove our SSH keys from the Git. So in order to do this, I'm typing in git rm cached, and I'm typing the name of the file and executing basically. Did I do any mistake? Yes, I did. This is non-existent file. Removed, you see. Now let's run again git status. So that file is not under Git anymore, and let's do the same thing for the second file. So yeah, it is removed. And now as you can see, my logo is added. So yeah, I can either commit it or do with it wherever I want. Let's go back to presentation and commands that we have here. Git commit I've shown you. Git branch. So Git branch actually creates a new branch. So I'm on main now. Git branch. Let's say I want to create a feature branch called feature1. So this is the command to do that. It's called git branch feature1. Feature1 is actually the name of the branch. And let me switch to that branch now. In order to do this, I need to use git checkout feature1. And let me run. You see that the reference changed. It says feature1 now, not main. And let me run git status. You see the changes rolled out to feature1 in the same form that they were on the previous branch. Now, if I, let's say, commit, let me commit the changes, basically adding my logo on this branch. And let's go look at our physical branch, at our physical repository. So here you can see that we have 3 files plus 2 keys, doc, tests, and Microsoft logo. If I switch back to main branch, git checkout main, let's see what's the list of the files there. You see, since I've committed my image on the feature1 branch, this file is no longer present here because I have switched between branches. So those kind of exist in different areas. Now, if I want to merge those branches, let's say the development of my feature1 is done, how can I do that? I can do git merge main and the name of the second branch. Now I'm showing you the happy path, no conflicts, no anything, because in real life there are usually conflicts that you need to resolve, and this is a bit harder using git bash. I'm usually suggesting, if possible, to use some UI clients because it's way faster for pretty average engineer in day-to-day activities. So let me try to merge them. Okay, it seems that all got merged. I'm on main branch, and if I go back to my folder, I have the logo here. So now I can actually delete the branch. Now, actually, let me go back to the list of the commands that we need to go through. So yeah, I've shown how to create branches now, how to check them out, how to switch to them, how to push changes. I have shown pull, merge, and fetch. So we basically went through all the major commands. Yeah, I guess other more specific commands like branch deletion and so on, you can just do some additional Googling. There is a list. There are lots of lists of commands. So if you feel interested, just please go and check them out. Let's continue with the presentation. Let's see what else we have. So branch and merge and changes. We actually just had that done. Not much to add here. Creating and uploading files that we actually went through as well. Yeah. So sorry guys. Let me get a bit. So yeah, that's basically it for this webinar. This is the list of the useful links, some just random links that I've used, but with useful information. It includes GitHub Home, GitHub Sign Up, generating SSH key and adding them to SSH agent, Git branching and merging strategies, how to push existing project to GitHub, a reference to the desktop app that you can try yourself. Plus, there are 2 links to committed tech community that is basically helping to host this webinar, and another link to Pro Quality community that I'm a part of. So if you're interested, go check that out. Let's move forward. Yeah, now it's time for Q&A session finally. So if you have any questions, please raise your hand or just type your question if you have any. So yeah, I don't have any questions in the moment. Folks, do you have any questions? Please raise your hand or type them in. And I will wait for like a minute. Let me stop the demonstration of the screen. Oh no, not yet. Let me leave it for now. And you should see it still. Okay, chat. Okay, thank you, Victor. No other questions here. Cool. Oh, there is in chat something else. I hope so, yeah. Okay, questions and answers. I have some. What is the difference between fetch, pull, and rebase? What should I, question from Sujit. What should I use for pulling updated repo without losing my individual changes? So, Sujit, fetch is not actually pulling anything. It's just like comparing your local repository and remote, and it calculates the delta, whether there are any differences. Now, if you're pulling, nowadays Git actually proposes to rebase if there are some conflicts. But if you actually want to be sure that you're safely pulling data from remote repository, always go with rebase. And you most likely will have to do it step by step. So yeah, I hope that answers. But yeah, just to be safe, for like a new user of a Git, it wouldn't hurt to do a copy of repository in some other place, not to lose your work, because I have cried a few times when I was starting initially working with Git, because sometimes it can be pretty confusing and complicated. So just to be safe, do a copy and go with rebase. If you're feeling brave, just go with rebase and be very careful comparing file by file and resolving deltas and separate conflicts between different files. So yeah, I hope that answers your question. Let me know if it's not or if some additional information is needed. Any other questions, anyone? Okay, yeah. So there will be definitely my contacts, my email, my something. I guess I will add my Skype to this presentation. So yeah, if you guys have any questions regarding version control systems, yeah, as an additional summary from my side, majority of my career I'm using Git, but I was working with SVN quite a lot, and I was also working with a mixture of SVN and Git, and it was a nightmare. So if by any time you're asked or proposed to work on the project where you have to merge stuff between SVN and Git, I would suggest to think twice. And I have also been working under TFS. With TFS, unfortunately, I faced lots and lots of issues, but it was a while ago, like 8 years ago. So my experience wasn't quite smooth, but yeah, it still worked and it was fine. Okay. Cool. Thank you, Pramod. Yeah, I was trying. Thank you, Eddie. Cool. In that case, yeah, I guess that's it with the presentation itself. Thank you, everyone, for joining the webinar and spending time here. Have a good Thursday time of your day, evening or midday or deep night or morning. Yeah, and once again, reminding you that there is a cool Azure free course that you can go and check out by scanning this QR code. So yeah, that's basically it. Thank you. Have a good evening.